Hey, what's up, little triglets? Time to get tricky with it. All right, today, section 3.5, and it has to do with the trig functions. This is the nitty-gritty. Trig functions. There are 6 of them. You know 3 of them. You know sine, cosine, and tangent. Let's review quickly the sides. Y over r for sine. Cosine is x over r. Tangent is y over x. Remember, that's opposite over adjacent. And you can also think of it as, see how this is y and this is x? You could think of it as sine over cosine. So there's 3 ways to think of tangent: y over x, opposite over adjacent, or sine over cosine. This is the one that I'll be using quite a bit as we move on through this stuff. Now, did you know that each of these had an evil twin? I know, it's a little scary, but now I'm going to put the evil twins in blood red. So the evil twin to sine, its name is cosecant, and that abbreviates CSC. The evil twin for cosine is secant, and the evil twin for tangent is cotangent. So cosecant, secant, and cotangent. And the reason they're evil is because they don't have any buttons on the calculator, and so it makes them harder to use. But when it's on paper, it's not that bad. So back here at the sine, we have y over r. Cosecant is just r over y. So it's just the reciprocal. Or another way you could put it is 1 over the sine. Okay, secant then would be r over x, or 1 over the cosine. Cotangent is x over y, or 1 over the tangent. Or, because of this right here, you could say it's cosine over sine. So, they're evil because we don't have buttons and they're a little more difficult to use, but when you do it on paper, if you can get sine, cosine, or tangent, you can figure the other ones out just by flipping them over. All right, so let's try a problem where we have to find the 6 trig functions. And don't forget, this is something kids forget all the time, that the first 3 letters in the word function spells fun. Okay, don't forget. There we go. Okay, so the terminal side of theta goes through the point 3, negative 4. I want you to find the 6 trig functions. Okay, so let's draw a quick sketch of it. Sketch always helps. So 3, negative 4. So I go, pretend like I'm going over 3 and down 4, and I'm landing right on the circle over here. So over 3, down 4. Let's label it 3 and negative 4. You're going to finish the triangle, and hopefully everybody knows this is a 3, 4, 5 triangle. So we plug that in. So x is 3, y is negative 4, and r is 5. So now all we have to do is do all the trig functions. So cosine, sine, tangent. Theta, you need to put the theta in there. Don't just get lazy and drop it off. So cosine is x over r, so 3/5. Sine is y over r, so negative 4/5. Tangent is y over x, or sine over cosine. The 5's would cancel, you get negative 4/3. Now the abbreviation for the evil twin of cosine is secant. and the evil twin of sine is cosecant. Do you notice what their first letters are? This is C and S, S and C. So the two C's will never go together and the two S's will never go together. That's another reason they're evil, is because they don't have the same letter as the good twin. So secant of theta, just flip it over, is 5/3. It's that easy. Cosecant of theta is negative 5/4, and cotangent of theta is negative 3/4. Don't make it harder than it is. It's not harder than that. All right, next page. If you're asked to find the domain of the tangent of theta, domain is like inputs that are legal. Now, legal in math means they don't make something that's undefined. Tangent, remember, is y over x. To something that would be illegal would if this were a 0. Okay, that would make it undefined. The symbol for undefined is that circle with the slash. So I want to know tangent. Another way to talk about it is sine over cosine. So if cosine were 0, then it would be undefined. So where is cosine 0? Cosine of theta equals 0 at, think of your circle. Cosine is your x. Where are you going so that you're not going to go right or left? Well, the places that you will go are straight up or straight down. Straight up. Straight up is pi over 2. Straight down is 3 pi over 2. See, this is where you're going to have to know your circle. Your circle is very, very important to figure these out. You're not going to want to figure them out by hand every single time. You just need to memorize it. So, theta cannot be pi over 2, 3 pi over 2, and then it could keep going. I could keep going all the way around and get another one, 5 pi over 2. Keep going, add pi again, and I would get 7 pi over 2. So I could go on forever and ever and ever. So the way this you can say this is that theta can equal any multiple of pi over 2. That would be how you should say the answer. I know that these are the answers, but there's millions more because you can keep going round and round the circle and get another one. Now, if you were in math class in college, they might say something like this. Now, I'm not going to make you do this, so don't panic. But the way they abbreviate in college would be like this. Okay, theta dot dot. Theta can be, or theta such that theta is not pi over 2 plus k pi, comma, where k is an element of the integers. Okay, so theta, we have theta as our answer, but theta cannot be pi over 2 plus any multiple. This k pi means multiple of pi, so adding pi will get you to the next one. So pi over 2, add pi to it, it gets you to the 3 pi over 2. But k has to be an element of z. Z is the letter they use to represent integers. So you get a page full of notation like this, and you look pretty dang smart. But we're not going to get that fancy. All you got to do is put this right here. Theta, actually theta cannot be, not can be, that's where it's illegal, is where it's multiples of pi. So theta cannot be any multiple of pi over 2. All right, the next thing I want to do, one more problem. Theta has a terminal side in quadrant 2. If Sine of theta is 12/13. I want you to find the other 5 trig functions. And don't forget what I said earlier. All right, so best thing to do, as soon as they start talking about quadrants, you should draw the triangle in that quadrant. So go X, Y, and finish the triangle. So the sine is 12/13. That means Y over R is 12/13. So over here, on the Y part, I'm going to put 12. On the R, I'm going to put 13. So our job is to find the X. Do Pythagorean theorem. X squared plus Y squared equals R squared. So 12 squared plus Y squared, actually X squared, equals 13 squared. So 144 plus X squared equals 169. Subtract. You get 25. So X equals plus or minus 5. Now your job is to figure out which one that is. So you look at where you are. You're in the second quadrant. You're going to the left. So it should be -5. So let's write down sine, cosine, tangent, cosecant, secant, cotangent. Evil twins. Sine is 12/13. Cosecant then would be 13/12. Cosine up here is x over r, so -5/13. Secant would be -13/5. Tangent is sine over cosine. 13's cancel and you're left with -12/5. The negative should just go on the top. And then flipping it over, I get -5/12. All right. There's one little warning thing I want to give you. Over here, let's do one more problem. For these, you need to change the decimal to a fraction before you start, because fractions are easier to flip over, decimals are not. Let's say I tell you that the cosine of theta is 1.95, and I want you to find the sine of theta. Well, those two are evil twins. I remember the C goes with the S, so these two are the evil twins together. But 1.95 is really 195 over 100. So if I flip that over, I get 100 over 195. Divide both by 5s, and I get 20 over 39. So the sine of that angle would be this. Okay, so if you get a decimal, turn it into a fraction. That makes it much easier to flip over. All right, that is it for today's lesson. Hope you got triggy with it. And don't forget, a little trig. Love goes a long way. Triggy.